Hello and welcome to another one of D's ADD videos. Today we're going to be discussing domain and looking at a few more advanced examples. Quick recap on the rules. Denominators can never equal 0. Set the denominator not equal to 0 and solve. Square roots have to be positive, so we set whatever's under the square root greater than or equal to 0 and solve. If the power of x is greater than 1, then we have to use sign analysis where we get some cut points and test on either side. Or if we have a fraction in there, we also do the same thing. The only difference if it's in the denominator is that we drop the equal sign, but the same restrictions occur. Okay. So let's look at this problem here. Now, first glance, you might be saying, "Oh, sign analysis," but notice that this fraction or the square root only goes on the numerator of the fraction, not on both the top and the bottom. So this, in actuality, is two problems in one, and you have to combine both answers. So we have 2 minus x that has to be positive. The way we say that is that. If you want to add the x to both sides, that's fine. Let's say you didn't see that and you divide by the negative. Don't forget to change your direction of the inequality. Either way, you should end up with that as part of your answer. And then the other part is that the bottom cannot equal 0. So we get that x plus 5, x minus 5, because it's a difference of two squares. And then you're going to get x cannot equal plus or minus 5. And then at that point, what do? Well, we draw a number line and combine your answers. Sorry, this is a retake on the video. First time the system crashed on me with the software, so I'm having to redo this. I'm a little frustrated. But it's okay. It's not the end of the world, right? So we put a closed dot at 2 because there's an equal sign there. And we shade to the left because it's saying x is less than 2. Well, there is one restriction to the left of it, and that occurs at the -5. There's an open dot there as well. Okay. Why is that? Because of this little gem right there. So if we combine both answers, note that the positive 5 is not even part of your region of interest. So your final answer would be negative infinity to -5. This is that -5 right there. Union -5 to 2. But the 2 gets a bracket because of the equal sign. Okay. Why did we not use sign analysis? Because only the numerator had the square root. Okay. Let's look at this next one. Yes, there is a denominator, but if we square a number that's positive, add a number to that that's positive, makes it more positive. So in other words, x squared plus 16 never equals 0. So the domain answer to that one is all real numbers. You don't even have to do any work. You could write never equals 0 if you want, but you don't need to. Then here we have a square root. The way we designate that in math is we say that it must be greater than or equal to 0. That's a first step. And now we've changed the domain question into what? An inequality question. And if you remember, whenever your inequalities have a power of x greater than 1 and one of those inequalities there, you have to use sign analysis. So we factor it. Factor further. Oops, no, that needs to be a -6, sorry. Yes, you could do by grouping. In this case, it's really not necessary. Unless you're trying to practice it, which by all means practice. Either way, you should end up with this as an answer. Draw your number line. Everybody gets a closed dot for this one. Positive 6, 0, and -3. If I plug in a -4, that's a negative, that's a negative, that's a negative. So 3 negatives give me negative. -1 gives me negative, negative, and a positive. So it's a positive. Positive 1 gives me a positive, negative, and a positive. It's a negative. And then 7 gives me a positive. So this is asking for where it was positive. So your final answer would be, see if I can squeeze it in here, -3 to 0, bracket, bracket, union 6 to infinity. Bracket for the 6 only. Okay? Alright. On this next one, you would just write all real numbers. There's no denominators. There's no square roots. You might say this is a denominator. Well, that's a denominator with no x's. You need a variable there for it to be a problem. And then here, finally, we have a fraction. So we set whatever's underneath the radical. Notice the whole fraction is in the radical. So you set it greater than or equal to 0. And then you're going to get 2 cut points of -2. You set x plus 2 equal to 0. And then 3x minus 9. So if we plot those, I guess I'll switch back to red now. You're going to get a -2 and a 3. 3 gets an open dot, even though this is an equal sign because it came from the denominator, whereas the 2 came from the numerator, so that equal sign actually applies. And then if I plug in a point to the left of -2, that's going to be like -3. That's a negative, and a negative is going to give me a positive. If I plug in a 0, that's a negative. Plug in a 4, that's a positive. And my final answer as a result would be -infinity to -2 union 3, that's a parentheses of a curve, to infinity. Okay? I hope I've cleared up any confusion you might have on domain. These are some more the advanced examples. So practice, practice, practice. You can see it can get tricky. Thank you and have a nice day.